العالمين.
All right, so with that said, let's go ahead and see what conditionals look like in Python. So in the left-hand side, again, here we'll see Scratch. And here, for instance, was just kind of a contrived example asking if x is less than y, then say x is less than y. In C, it looked like this. In Python now, it's going to look like this instead. And here's before in C, and here's after. And just to call out a few of the obvious differences, what has changed in Python for conditionals, it would seem? Sort of, what's the difference? Yeah. Yeah, so there's no more curly braces, and indeed you don't use those. What appears to be taking their place, if you might infer? What seems to have taken their place? What do you think? So the colon at the start of this line here, but also even more important now is this indentation below it. So some of you, and we know this from office hours, have a habit of like indenting everything on the left, right? And it's just kind of this crazy mess to look at. Frustrating for you, surely. But C and Clang is pretty tolerant when it comes to things like white space in a program. Python, They realized years ago that let's help humans help themselves and just require standard indentation. So 4 spaces would be the norm here. But because it's indented below that colon, that indeed indicates that this now is part of that condition. Something else has gone missing versus C in this conditional. What else is a little simplified? Yeah, so no more parentheses. You can still use them, especially when you need to logically to do order of operations like in math. But in this case, if you just want to ask a simple question like if x less than y, you can just do it like that. How about when you have an if else? Well, this is almost the same here with these same changes. In C, this looked like this. And it's starting to get a bit bulky, at least if we use our curly braces in this way. In Python, we can tighten things up further, even though strictly speaking in C, you don't always need the curly braces. But here, gone are the parentheses again. Gone are the curly braces. Indentation is consistent. And we've just added another keyword else with a colon, but no more semicolons as well. How about something larger like this? An if, else, if, else. This one's a little curious, but in C it looked like this. If, else, if, else. In Python, it now looks like this. And there's perhaps one curiosity here that honestly, all these years later, I still can't remember how to spell it half the time. What's weird about this? What do you spot as different? Yeah, over here. Yeah, instead of else if, it's elif. Why? Apparently else space if was just too many keystrokes for humans to type, so they condensed it into this way. Probably means it's a little more distinguishable too for the computer between the if and the else too, but just something to remember now. It's indeed elif and not else if. All right, so what about variables in Python? I've used a couple of them already, but let's distill exactly how you define and declare these things as well. So in Scratch, if we wanted to create a variable called counter and set it equal initially to 0, we would do something like this. Specify that it's an int, use the assignment operator, end the thought with a semicolon. In Python, it's just simpler. You name the variable, you use the assignment operator as before, you set it equal to some value, and that's it. You don't mention the type, you don't mention the semicolon or anything more. What if you want to change a variable like the counter by 1, that is increment it by 1? You have a few different ways here in C. We saw syntax like this, where you can say counter equals counter plus 1, which again feels like illogical. How can counter equal counter plus 1? But again, we read this code really right to left, updating its value by 1. In Python, it's almost the same. You just get rid of the semicolon. So that logic is there. But recall in C, we could do something slightly different that we can also do in Python. In Python, you can also more succinctly do this. Plus equals, and then whatever number you want to add, or you can even change it to subtract if you prefer. Sadly, gone is something you've probably typed a whole lot. What was the other way you can add 1? Plus plus is no more, sadly, in Python. Just too many ways to do the same thing, so they got rid of it in favor of just this syntax here. So keep that in mind as well. What about loops? When you want to do something in Python again and again? Well, in Scratch, in week 0, here's how we meowed 3 times specifically. In C, we had a couple of ways of doing this. This was like the more mechanical approach where you create a variable called I, you set it equal to 0. You then do while I is less than 3, the following, and then you yourself increment I again and again. Mechanical in the sense that like you have to implement all of these gears and make them turn yourself, but this was a correct way to do that. In Python, we can still achieve the same idea. But we don't need the int keyword. We don't need any of the semicolons. We don't need the parentheses. We don't need the curly braces. We can't use the plus plus. So maybe that's a minor step backwards if you're a fan. But otherwise, the code, the logic is exactly the same. But there's other ways to achieve this same idea. Recall that in C, we could also do this. You could use a for loop, which it does exactly the same thing. Both are correct. Both are arguably well designed. It's kind of to each their own when it comes to choosing between these. In Python, though, we're going to have to think through how to do this. So you don't do the same for loop as in C. The closest I could come up with is this, where you say for I, or whatever variable you want to do the counting, in, literally, the preposition, and then you use square brackets here. And we've used square brackets before in the context of like arrays and things like that. And the 0, 1, 2 looks like an array in some sense, even though we've also seen arrays with curly braces. But these square brackets for now denote a list. Python does not have arrays. An array is that contiguous chunk of memory back to back to back that you have to resize somehow by moving things around in memory, as per 2 weeks ago. In Python, though, you can just create a list like this using square brackets. And better still, as we'll see, you can add or even remove things from that list down the road. This, though, is not going to be very well designed. This will work. This will iterate in Python 3 times. But what might rub you the wrong way about this design, even if you've never seen Python before? How does this example not end well? Yeah? Yeah, like if you're making a large list, you have to type out each one of these numbers, like comma 3, comma 4, comma 5, comma dot 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 50, comma dot 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 500. Like surely that's not the best solution to have all of these numbers on the screen wrapping endlessly on the screen. So in Python, another way to do this would be to use a function called range, which technically is a data type unto itself. And this returns to you as many values as you ask for it. Range takes some other arguments as well, but the simplest use case here is if you want back the numbers 0, 1, and 2, a total of 3 values, you say, hey, Python, please give me a range of 3 values. And by default, they start at 0 on up. But this is more efficient than it would be to hard code the entire list at once. And the best metaphor I could come up with is something like this. Like here, for instance, is a deck of cards. This is sort of normal human size. And there's presumably 52 cards here. So writing out 0 through 51 on code would be a little ridiculous for the reasons you note. It would just be very unwieldy and ugly and wrapping and all of that. It would be the virtual equivalent of me like handing you all of these cards at once to just deal with. And right, you know, they're not that big, but like it's a lot of cards to hold on to. It requires a lot of memory or physical storage, if you will. What range does metaphorically is if you ask me for 3 cards, I hand you them one at a time like this, so that at any point in time, you only have one number in the computer's memory until you're handed the next. The alternative, the previous version, would be to hand me all 3 cards at once or all 52 cards at once. But in this case, range is just way more efficient. You can do range of 1,000. That's not going to give you a list of 1,000 values all at once. It's going to give you 1,000 values one at a time, reducing memory significantly in the computer itself. All right, so besides this, what about doing something forever in Scratch? Well, we could do this literally with a forever block, which didn't quite exist in C. In C, we kind of had to hack it together by saying while true, because true is by definition, TRUE, always true. So this just deliberately induces an infinite loop for us. In Python, the logic's going to be almost the same. And infinite loops in Python tend to actually be even more common, because you can always break out of them, as you could in C. In Python, it looks like this. And this is slightly more subtle, but gone are the curly braces, gone are the parentheses, but ever so slight difference too. A capital T for true, and it's going to be a capital F for false. Stupid little differences. Eventually, you're going to mistype one or the other. But these are the kinds of things to keep an eye out and to start recognizing in your mind's eye when you read code. Questions now on any of these building blocks? Yeah? In the for loop was it was set to 0 on the first iteration, then 1 on the next, then 2 on the third. And the same thing for range. It just doesn't use up as much memory all at once. Other questions now on any of these building blocks of Python? No? All right, well, let's go ahead and build something a little more than hello. Let me propose that over here we implement maybe the simplest of calculators here. So let me go back to VS Code here, open my terminal window and open up, say, a file called calculator.py. And in calculator.py, we'll have an opportunity to explore some of these building blocks, but we'll allow things to escalate pretty quickly to more interesting examples so that we can do the same thing ultimately as well. And in fact, let me go ahead and do this moreover. I've brought some code with me in advance. For instance, something called calculator 0.c from the first week of C. And let me go ahead and split my window here, in fact, so that I can now do something like this. Let me move this over here. Calculator.py. So now I have on the left of my screen calculator.c, or calculator0.c, because that's the first version I made, and calculator.py on the right. Let me go ahead and implement really the same idea here. So on the right-hand side, the analog of including CS50.h would be from CS50 import getInt, if I want to indeed use this function. Now I'm going to go ahead and give myself a variable x without defining its type. I'm going to use this getInt function, and I'm going to prompt the user for x, just like in C. I'm then going to go ahead and prompt the user for another int, like y, here, just like in C. And at the very end, I'm going to go ahead and do print x plus y. And that's it. Now, granted, I have some comments in my C version of the code, just to remind you of what each line is doing. But I've still distilled this into like 6 lines, or really 4 if I get rid of the blank line. So it's already perhaps a bit tighter here. But there's also, it's tighter because something really important historically is missing. What did I seem to omit altogether that we haven't really highlighted yet? Yeah, the main function is gone. And in fact, maybe you took for granted that it just worked a moment ago when I wrote hello. But I didn't have a main function in hello either. And this, too, is a feature of Python and a lot of other languages as well. Instead of having to adhere to these long-standing traditions, if you just want to write code and get something done, fine. Just write code and get something done without necessarily all of this same boilerplate. So whatever is in your Python file, left indented, if you will, by default, is just going to be the code that the interpreter runs top to bottom, left to right. Well, let me go ahead now and run code like this. Let me go ahead and open back up my terminal window, run Python of calculator.py, and I'll do x is 1, y is 2. And as you might expect, it gives me 3. Slight aesthetic bug. I put my space in the wrong place here. So that's a newbie mistake. Let me fix that aesthetically. Let me rerun Python of calculator.py, type in 1, type in 2, and voila, there is now my same version again. But let me propose now that we get rid of this training wheel. We don't want to keep taking 1 step forward and then 2 steps back by adding these training wheels. So let me instead do this. In my version of calculator.py, suppose that we take away already the training wheel that is the CS50 library here. And let me instead then use just Python's built-in function called input, which literally does just that. It gets input from the user. And it stores it, as before, in x and y. So this is not CS50 specific. This is real-world Python programming. Well, let me go ahead and run, again, Python of calculator.py. And of course, if x is 1 and y is 2, x plus y should, of course, still be 3. It's apparently 12, according to Python, until CS50's library gets involved. But does anyone want to infer what just went wrong? Yeah. Exactly. The input function, by design, always returns a string of text. After all, that's what the human typed in. And even though, yes, I typed the number keys on the keyboard, it's still coming back as all text. Now, maybe we should use like a getInt function. Well, that doesn't exist in Python. All you can do is get textual input, a string from the user. But we can convert one to the other. And so a fix for this, so that we don't accidentally concatenate, that is, join x plus y together, would be to do something like this. Let me go back to my Python code here. And whereas in C, we could previously do typecasting. We could convert one type to another. That generally wasn't the case when you were doing something complex like a string to an int. You could do a char to an int and vice versa. But for a string, recall there was a special function in the C-type library called a to I, like ASCII to integer. That's the closest analog here. And in fact, the way to do this in Python would be to use a function called int, which indeed is the name of the data type too, even though I have not yet had to type it. And I can convert the output of the input function automatically from a string immediately to an int. And now, if I go back to my terminal window, rerun Python of calculator.py with 1 and 2 for x and y, now I'm back in business. So that then is, for instance, what the CS50 library does, if temporarily this week, is it just deals with the conversion for you. And in fact, bad things could happen if I type the wrong thing, like dog or cat instead of a number, but we'll cross that bridge in just a moment as well. All right, what if we do something slightly different now with our calculator? Instead of just addition, let me go ahead and do, how about, instead of addition, let's do division instead. So z equals x divided by y, thereby giving me a third variable z. Let me go ahead and run Python of calculator.py again. I'll type in 1, I'll type in 3 this time. And what problem do you think we're about to see? Or is it gone? What happened when I did this in C, albeit with some slightly more cryptic syntax? When I divided one number, like 1 divided by 3. Anyone recall? Yeah. Yeah, so it would round down to the nearest integer, whereby you experience truncation. So if you take an integer like 1, you divide it by another integer like 3, that technically should be 0.33333, infinitely long. But in C, recall, you truncate the value. If you divide an int by an int, you get back an int, which means you get only the integer part, which was the 0. Now, Python actually handles this for us and avoids the truncation, but it leaves us still with one other problem here, which is going to be, for instance, not necessarily visible at a glance. This looks correct. This has solved the problem in C. So truncation does not happen. The integers are automatically converted to a floating point value. But what other problem did we trip over back in week 1? What else got a little dicey when dealing with simple arithmetic? Anyone recall? Well, the syntax in Python is a little different, but let me go ahead and do this. It turns out in Python, if you want to see more significant digits than what I'm seeing here by default, which is a dozen or so, let me go ahead and print out z as follows. Let me first print out a format string, because I want to format z in an interesting way. And notice this would have no effect on the difference. This is just a format string that, for no compelling reason at the moment, is interpolating z in those curly braces using an f string or format string. If I run this again with 1 and 3, we'll see indeed the exact same thing. But when you use an f string, you indeed have the ability to format that string more precisely. Just like with %f in Python, you could start to fine-tune how many significant digits you see. In C, in Python, you can do the same, but the syntax is a little different. If you want the computer to interpolate z and show you 50 significant digits, that is 50 numbers after the decimal point, syntax is similar to C, but it's a little different. You literally put a colon after the variable's name. .50 means show me the decimal point and then 50 digits to the right. And the f just indicates, please treat this as a floating point value. So now if I rerun Python of calculator.py, divide 1 by 3, unfortunately, Python has not solved all of the world's problems for us. This, again, was an example of floating point imprecision. So that problem is still latent. So just because the world has advanced doesn't necessarily mean that all of our problems from C have gone away. There are solutions using third-party libraries for scientific calculations and the like. But out of the box, floating point imprecision is still an issue. Meanwhile, there was one other problem in C that we ran into involving numbers, and that was this: integer overflow. Recall that an integer in C only took up, like 32 bits typically, which meant you could count as high as 4 billion, or maybe if you're doing positive and negatives, as high as 2 billion. After which, weird things would happen. The number would go to 0 or negative, or just it would overflow or wrap back around. Well, wonderfully in Python, they did at least address this, whereby you can count as high as you want. And Python will just use more and more and more and more bits and bytes to store really big numbers, so integer overflow is not a thing. With that said, Python is limited to how many digits it will show you on the screen at once as a string. But mathematically, your math will be correct now. So we've taken a couple steps forward, one step sideways. But indeed, we've solved some of our problems here. All right, questions now on any of these examples thus far? Question.